Good morning, everyone. It's my pleasure to welcome you to the MIT Technology Licensing Office Golden Speaker Series. As you probably already know, MIT is renowned for its faculty, researchers, and leadership in impact in the world. Today and Friday, we have the privilege of hearing from some of those faculty. Briefly about the Technology Licensing Office, we manage MIT's intellectual assets. Whether patents, copyright, software, tangible property, we work with faculty and researchers to identify suitable licensing partners, whether startup or established companies, and that work is undertaken by 50 highly professional and qualified staff at the TLO. MIT, through the TLO, has transferred technology related to high-powered semiconductors, communication devices, optical networks, photovoltaics, new coatings for consumer products, digital signal processing, therapeutics for bladder, breast cancer, hearing loss, data analytics, battery technology, CO2 mitigation, filtration for industrial waste streams, and the list goes on. And I haven't even touched those being presented on today and Friday. So sit back, relax, and enjoy your journey through MIT's impact in the world. Kevin?
Good morning, everyone. I'm Kevin Hogan, also from the Technology Licensing Office. I'm a licensing officer managing a portfolio of inventions and software from MIT faculty and students. As a former software and firmware embedded systems engineer, I manage a portfolio around artificial intelligence, communications, algorithms, cybersecurity, information and data technology, as well as MIT's open source software policies and releases. I've only been with MIT about 6 months, but in that time I've had the privilege of working with our first speaker, Muriel Médard, on a number of times. And it's been really good to kind of get my feet warm with somebody so accommodating and welcoming as Muriel, as any of her students can probably attest. Among many innovations, she's a pioneer in network coding systems. Her noise-centric decoding, called Guessing Noise Additive Noise Decoding, GRAND, uses recent developments to remove the effect of noise in network decoding. Her advances in this area resulted in a number of patents in her portfolio, including a chip that will have major impact on the evolution of network communications worldwide. She is the NEC Professor of Software Science and Engineering in the School of Engineering at MIT, and a Professor of Electrical Engineering and Computer Science in the EECS department at MIT. She leads the Network Coding and Reliable Communications Group in the Research Laboratory for Electronics at MIT, and is Chief Scientist for Steinwurf, which she co-founded. She has 3 bachelor's degrees, as well as her MS and SCD, all from MIT. She's a member of the US National Academy of Engineering, a member of the German National Academy of Sciences, Leopoldina, a fellow of the US National Academy of Inventors, American Academy of Arts and Sciences, and a fellow of the Institute of Electrical and Electronics Engineers. She holds honorary doctorates from the Technical University of Munich and from the University of Aalborg. She was awarded the 2022 IEEE Kobayashi Computer and Communications Award, the 2017 IEEE Communications Society Edwin Howard Armstrong Achievement Award. This is like going to be like the Oscars, right? They're going to music me out on your achievements. But also, she's the co-winner of the MIT 2004 Harold E. Egerton Faculty Achievement Award and was named a Gilbert Lecturer by the US National Academy of Engineering in 2007. She's the editor-in-chief of the IEEE Transactions on Information Theory and served previously as editor-in-chief of IEEE Journal on Selected Areas of Communications and was selected president of the IEEE Information Theory Society in 2012 and serves on its board of governors, having previously served for 11 years. She supervised over 40 master's students, 20 doctoral students, and 25 postdoc fellows. She received the inaugural MIT Postdoc Association Mentoring Award in 2022, and the inaugural MIT EECS Graduate Student Association Mentor Award, voted by the students in 2013, which really speaks to her contributions among the students here at MIT. She set up Women in Information Theory Society and Information Theory Society Mentoring Program, for which she was recognized with the 2017 Aaron Winter Distinguished Service Award. She has over 60 U.S. and international patents awarded. The vast majority have been licenses or acquired through collaboration with the MIT TLO. She co-founded Codon for intellectual property licensing and Steinway for reliable and low latency networking. She also serves on the Nokia Bell Labs Technical Advisory Board. So after Muriel's presentation, we'll be taking Q&A. So if you're remote, please feel free to put your questions on the Slido deck, and we'll upvote them and try to get to them as well as we can during that time. But all, thank you for coming, and please welcome Professor Muriel Médard.
Thank you. Thank you very much, Kevin. Thank you, Leslie, and the whole team at TLO for inviting me. And I know there's a lot of people online. Thank you for being online. And thanks to the people who braved the bad weather and the even worse traffic this morning. So what I'm hoping to do today is to talk to you about half an hour. Maybe it'll be inspiring, maybe a cautionary tale, but, you know, sort of intersperse notions of entrepreneurship and intellectual property in a more personal narrative. And, you know, my husband always says that the plural of anecdotes is not data. But, you know, that's all we have. All we have is anecdotes. So I'm hoping that it's not going to be data, but at least it may be interesting. Now, I had an alternate title, which I wrote, and which was A Journey of Research, Invention, Entrepreneurship, and Quite a Few Patents Along the Way. And then I realized that really sounded like I knew what I was doing all along. And, you know, if I was honest with myself and with you, that's really not what was happening. So I thought maybe I would just say how things went, which was embracing randomness. And some reflections on life and career, which I hope may be of interest or at least of amusement. Okay, so as you can tell maybe from my name, my background is French. I came here from France as a student. I don't know if people know who this guy is, but this guy is Marivaux. So he basically wrote 18th century rom-coms. But, you know, one of the titles of one of his best-known rom-coms basically is Le jeu de l'amour et du hasard. So it's, you know, the game of love and chance, right? So, you know, it's about as corny as it sounds. But you know, what I really like here is this interplay, right? The jeu is also an interplay. And you know, if you look at his many, you know, fairly formulaic but, you know, fun little plays, you know, there's sort of three components. And the first is what we thought was familiar may not be true, right? So, you know, you have people changing roles, very Shakespearean also. You throw some randomness in there, even if it looks risky, right? And people do things that, you know, a priori look like that's really not going to work. But the last one is also they solve a different game, right? So you think you're optimizing for one thing, but you actually end up optimizing for something else. And you know, these motifs sort of show up over and over again in these plays. So let me start with, you know, what does that have to do with us, you know, in the 21st century, and obviously, you know, not looking for 18th century dating advice, but rather maybe for some professional guidance. So, you know, I've tried to distill sort of the received wisdom out there, you know, so what do we think that we're optimizing for? And, you know, without wanting to be, more of a caricature, you know, there's this idea that you specialize and you very focus on one specific problem, okay? And you know, if you're going to be successful, you really need to specialize. And then, you know, you really need to curate your career from very early on by taking very well selected, prestigious internships at particular firms or in particular groups. And, you know, there's also this notion that you can sort of spot a winner, right? That, you know, often called the golden young person, right? It's generally called the golden boy, but let's just call it the young person who is, you know, from early on, you know, destined, you know, they have a star on their forehead, and you can just see that, you know, they're absolutely going to go places, and you just need to follow them, and you know, later on when they act weird, you just assume that it's because they're so brilliant and you don't get them. You know that basically the rest of life, such as, you know, family or other, other interests, and I mean family broadly, whether it be, you know, children or other, duties to other members of the family, should be really delayed or put aside to focus on the career. And also, I think this is particularly true for academics, that, you know, if you want to become an academic, you have to have, you know, a single-minded, maybe you could call it monomaniacal approach to your career, where that's the only thing you could ever think of yourself as doing, and, you know, you just have to get on that and never get off that path. So I think I knew this, but I didn't register. So that's not what I did, okay? And I think one of the reasons for sharing this is also, you know, you here in the room, online, you may be at different stages in your life or different stages in your thinking about what you want in your life. And you may not feel that you're really following that recipe, and that somehow falling off that track is somehow, you know, an irreversible step. So Kevin mentioned I had a triple major, but, you know, I majored in electrical engineering, in math, but also in humanities. And when I mean humanities, I mean 19th century Russian literature, okay? Like, it is absolutely not something that you're gonna, you know, use in your CV and trying to you know, start a tech company. My summer jobs were a random assortment of things that do not show up on my CV. Don't look for them, because, you know, I for a long time I just excised them. But basically, I was teaching aerobics and working in gyms. I had contracts with the Air Force for teaching aerobics to the special police, you know, and this is what I did. There were many reasons, again, family reasons, so on and so on, while I was going to random places, you know, small villages in Texas, and, you know, out in Korea and so on, and, you know, taking time to do these activities, while, you know, my peers were doing internships typically at Bell Labs, you know, of which I'm now on the technical advisory board of, you know, with a lovely twist. And, you know, the whole thing about the young prodigy, I did not develop or find an aptitude for math until my teens. This is not maybe typical, but, you know, it also means that you can get into it later. You know, at one point in my teens, I decided I was actually going to understand this, and I just sat down and literally figured it out. Around the age of 12, 13, I just sat down and decided to figure it out. And I think it's more a question here about determination, in my view, rather than, you know, inherent brilliance. You know, not that you don't have people who obviously are in, you know, just off the charts, but, you know, most people get somewhere just because they decide to figure it out. I really think the vast majority of people can get a degree in math at MIT, literally. You know, if they put their mind to it, absolutely. You know, so I think it's much more about putting the work in. And you know, I volunteer a lot at my son's schools, which is the International School of Boston, Lycée International de Boston. And, you know, I was talking to math students, and I said, you know, you too can become, you know, a student with perfect grades in math. And I had found, you know, in my basement, one of my math tests where I had a 5 out of 20. Okay, 5 out of 20. And then, you know, later in the year, I had a 20 out of 20. But what I was trying to tell them was like, this was the level I was at. This was the level I got to. It's all really about being very determined. I didn't delay my family. I got married at 19, my first marriage. I have 4 kids. Here you can see the kids and my son-in-law. You know, the other thing about being monomaniacal about academia, I did not think of going into academia when I was graduating. I went into engineering because I wanted to be an engineer. I went to work at MIT Lincoln Lab, with which I still have wonderful collaborations. And I just went there to see, you know, what was going on, what to do, and also because I wanted to get some more practical experience. So, the reason to bring this up is that, there are many different ways to get to the CV that Kevin just mentioned, which is, in effect, an academic engineering CV. Okay, and a lot of it is really just again, working. I mean, you might say, well, how does the doing doing aerobics in small towns in Texas counts in that? Try waking up every morning at 5 a.m. because you got the worst shift, and you have to go and clean out all the weights that haven't been put away, and teach again. It's hard work, and it counts. It absolutely counts towards whatever you're going to be doing later and doing well. So this is definitely my my path. So I'm hoping to address sort of the first item here, which is what we thought was familiar may not be true. Now, a little bit about throw some randomness in there, even if it looks risky. And, this has been organized by TLO, and a lot of what we do with TLO as faculty members is we work on patents, right? I mean, to me, the way I describe patents, it's sort of the vehicle by which you take innovation and you transfer it. It's like it's what makes an idea an actual transferable unit. Obviously, we write papers, and those convey those ideas in their own way. But they're not an item that can actually be transferred in my view. So, how did I get involved in patents? So, completely by chance. So, getting into this randomness, I mentioned when I graduated, I went to work at MIT Lincoln Lab. It was a very common path from, graduated doctoral student. I had no idea what I wanted to do. My advisor, Bob Gallagher, had suggested I look into academia, and I think I actually laughed in his face. And I'm afraid I said something along the lines of, why would I want your job? It looks awful. I felt bad about it later when I was in the same lab as him as an academic. But I didn't see myself in that role. I didn't see myself in that role. I didn't see myself supervising students. I didn't see myself writing proposals and having to raise tons of money. I didn't see myself doing that. So I went to Lincoln Lab, and since I didn't know what I wanted to do, I took the only job that had nothing to do with my PhD. I figured I'm going to go and I'm going to learn something. So I had multiple offers. By the way, I only interviewed 2 places because they were both within a couple of miles of my daughter's preschool, because she really liked that preschool. Okay, this is what I'm saying about really not following the, go to the best job career path. And within that, so I took a job in optical communications, and within that, I took a project that possibly had like a police line, do not cross line around it, because it just looked like it was way too risky. Now, the way I looked at it is I was just going to do this for a couple of years and then see where I was going. So I would do my best, and then if it didn't work out, I'd do something else. I wasn't, whatever, right? You're in your 20s and you have a PhD from MIT, you'll be okay. You really will be okay. It turned out to be in optical network security, to be absolutely fascinating, and there was a lot of stuff that was patentable. I did not know about patents. I learned about patents on that job. And I was also extremely lucky to sort of start working on patents with a fantastic attorney, Chris Daly, and who was also starting out as his career, who had been an engineer, was now a patent attorney, and to sort of co-develop our careers. He, of course, has many other clients, but, co-developed the career, and really he helped me understand, and we sort of symbiotically followed each other in terms of developing intellectual property. And I realized that, as an engineer, doing patents is actually, once you get to the first shock of looking at stuff that looks like gobbledygook, is actually very, very natural. It is very much like coding. It's very much about logic. It's very much about being precise. We know how to do this. And with that, I also became involved to be an expert witness. Now, the first few times I was asked to be an expert witness, I said, absolutely not. I didn't want to be involved in something that was, in effect, almost, inherently I felt unpleasant, right? That there was an opposition, that that there was maybe some underlying belligerence. It's just not my style. And really, when I started, I also thought, and probably correctly at the time, that there would be no place for a woman with a high voice, talking about technical stuff. So I only did things, if you will, behind the scenes. I would actually write things like invalidity claims, or look at whether they were whether infringement, an infringement case and so on. But I would do it all non-discoverable. I would do the work, and then they would hire a guy, to go in front of the judges, and often I was very honest with the firms. I said, look, yes, I can do this better than anybody. You came to me because of my publications, but trust me, I'll do the work, and you can then, of course, do what you want with it. It's owned by you. But of course, eventually, I realized, I think times have changed, and my CV had changed, and that, of course, I could go and do it. And I think one of the things I really found very empowering is, again, with this issue of the logic, is, the power of reason argument over other adverse conditions or constructs that often, particularly I see several women that often sort of lower our voice in some way, no matter how loud we may be, so sort of really doesn't, in the end, happen that much in court. This was a discovery, a random discovery, which I think to me was very, very positive. I'm not saying everybody should get involved in patents. It's a lot of work. I have to say, when you get good at it, it's extremely satisfying. It has made me a better inventor. There's absolutely no doubt that even as I'm doing my research, this has helped. I understand better what is and what is not a contribution. I mean, there is research I do sometimes just for yucks. I mean, let's face it, I also do word puzzles, Sometimes you just do it because it's fun, and why not? And, occasionally it goes somewhere. But, it's really distinguishing between the stuff that may have an impact, that you could actually go to somebody and say, I think you should take this, and I think you should take this, and I think that this is going to make your product better. I think that's been a huge, huge learning opportunity. Okay, and I think it helped me very much then when I did, sort of what I would call my first sort of major technical push or effort or contribution, past my postdoc and past, the Lincoln Lab work. By the way, the Lincoln Lab work ended up going extremely well, even though it was very risky, and that's how I got a job here, basically, So it was a risk, but it was definitely I was very fortunate. So the idea behind network coding, which was just mentioned, is that, you can take data, and, we think of data as packets, as, basically things that you send around, but of course they happen to be numbers, and they happen to be, therefore, fungible in some way, right? So for me to give you packet 1, packet 2, packet 3, packet 4, or for me to give you 4 equations which allow you to then reconstruct those packets is the same, right? It's the same. It's the same data. You have the same information. Now you say, why on earth would you give me those 4 equations versus, the original ones? Well, it turns out you really need to have a lot of fluidity, a lot of flexibility in representing, particularly in order to have low latency and in order to have reliability. So, now if one of the packets gets lost, I may just be able to substitute any old equation for the first one. And then, this whole thing of randomness, this is sort of where the math really came in well. We think of data mostly as being binary, bits, zeros and ones. It turns out, a lot of people had been trying to do this with binary, and you can't. You need to have taken more math. You need to go to, higher order Galois fields, and then all of a sudden things go well. And you also need to have trust in doing probabilistic and random algorithms, which a lot of, again, most people did not trust random algorithms, right? So also having the background in probability was extremely useful. And with this, I went ahead and I built a very deliberate portfolio of patents. And TLO backed me. Basically, they were willing to invest in building this portfolio and, built a lot of patents. Now, I had done some patents with them before, say in the optical domain and security, and people either looked at licensed them or they had licensed them. So I had other, odds and bobs that had been licensed, a patent here, a patent there. But it was a lot of trust in the end, right? It was a lot of trust. I mean, yes, obviously I could A, patent successfully, B, it wasn't just complete fluff nonsense that, nobody wanted to at least, put some money in. But, we're talking now tens of patents. And my journey there was a little interesting. Maybe I'll stick with this a little bit. I started looking at how to do tech transfer. And the initial thought was just, create a company, go with a venture capital to back that company. Perfectly standard stuff. So why not do that? There were a couple of reasons. I mean, the first one was I wasn't entirely sure what was the best. Some of them good, some of them bad. I wasn't entirely sure what was the best use case. There were many, many use cases. There were some for security, there were some for reliability, there were some for low latency, et cetera, et cetera. So, there was some uncertainty as to exactly what the company would do. So that, I think, was a good reason because, I didn't want to sort of bet on something when I wasn't quite sure. The other one was a bad reason, it was naive, which was that I thought, well, that there's the patent, there's the papers, surely people can read them and, develop the technology, right? And the reason that was a bad reason, even though it sounded reasonable enough, is the following. First of all, the papers were highly specialized, right? So the principles were easy, but the papers were, papers in the kind of journal of which I'm an editor-in-chief right now, it's a very specialized audience to read those papers, even if the technology in the end is maybe much more straightforward to implement. The second one that I hadn't, so that was one reason why that was a bad reason. The second reason why my reason was a bad reason was that, because it was very heterodox, people didn't trust it. Never mind that you had done all the proofs. People don't actually read the math. So it looked like it wasn't going to work, and there were a lot of people saying it wasn't going to work. And so what I should have done much earlier was actually do a demonstration in a way that was not just a high-level demonstration, but something that I could hand to people and they could try it out. And the third reason why it wasn't such a good reason is because, people have other things to do also. Generally a company is making a product, they're in the course of doing business and developing the next product, and they can't just grab a team of engineers and say, go and do this, read these papers, get up to speed, and come back to me once you figured it out. And the times when they try to do that, those engineers then get pulled in to do other things. It's always going to be, something that's going to completely change your product in 5 years is always going to be at the bottom of the stack. Forever, and it's like, even when it gets to the top of the stack, something else gets put in and down it goes, okay? And so those were really the three sort of components why my second reason of, well, if you build it, they will come, was wrong. So first, I, with some collaborators and some, again, figuring it out as I went along, sort of created Codon, which is a company for the intellectual property licensing, so working closely with TLO, also to get some licenses from other universities. Certainly one of the things I found was, Kevin very kindly talked about all my mentoring activities and so on, and being on the board of governors, being elected to be president. This is of a society which has like maybe 10% women, electing me, and so on. That having those very positive contacts, and that's not the reason why I had those very positive contacts, but it was certainly extremely useful. That I knew what everybody was doing. Everybody was telling me what they were doing. They were seeking advice. I was seen as sort of a mentor in the society, meant that also I really knew, whose work was worthwhile, exactly what was happening, and therefore able to sort of identify what patents we needed to get maybe from other universities, and sort of creating a body for that with licensing professionals was one of the things to do. So that was sort of about putting together the intellectual property. The second part, which was then, okay, now you have the rights, and now they make sense, and now you could transfer them. The second part about actually making something tangible led me to start a company, which is actually in Denmark, in Aalborg. So as you heard, I have connections to University of Aalborg, and you may say, why does she have a honorary doctorate from University of Aalborg? Well, I've done a lot of work there because I had collaborators there, same way that a lot of my work was also with Technical University of Munich, where I also was very kind to give me a honoris causa doctorate. And the idea here was actually you need to make the software, right? Now, again, remember, I thought that people could make it, and it's not that they couldn't. It's just, it was a huge effort for them, and they had other things to do. So you really needed to pull together a team that was going to just make the software so that people didn't have to understand the math, not because they're dumb, just because they've got other things to do, right? They can't be spending the time just understanding your papers just because you think they're great. Doesn't mean that they don't have other things to do. And that's basically what we've been doing now, and that licenses the network coding portfolio that I mentioned before, and then this makes it into other companies. I mentioned about the fact that I wasn't sure, that it was good for me not to jump when I didn't quite know which area was good. It turns out this was a good way to figure out what was the pull from the market. Some of it was things I would expect, like, really highly challenged communications, like underwater communications. They came and they said, we need this. The other one was actually SDN, software-defined networking. Barracuda came and asked us for this, and, they put it in, and then, correlation or causation, they jumped to the top of the stack in the yearly benchmarking. And then other people come to you, and it's public knowledge now, but there will be an announcement that now Cradlepoint, which is part of Ericsson, is also putting in this in their products, okay, which is that's their SDN, the SDN arm of Ericsson. So it took a while, and frankly, I didn't think it would be this hard. I'll tell you, okay. And would I have done it if I had known it was this hard? I don't know. Probably I would have thought about it a little bit more, but maybe I would have, just out of sheer stubbornness or whatever you may want to call it. And now I just want to go a little bit to the third point, which is, this idea of solving a different game. That's very much in line with what I've been doing recently, which again, Kevin also mentioned, universal decoding. So right now, decoders try to recognize messages. So, you have your phone, and your phone talks to a cell tower, and stuff happens in between. There's interference from, the Wi-Fi, from just electromagnetic noise, microwaves going off, whatever you may want, just the electronics themselves. And so, the messages get in some way change, corrupted. And then there's, patterns that you put so that then the messages look recognizable. Like you can recognize a pattern and then you can try to undo the noise by looking at patterns. And it's very complicated, it's very mathematical. There are whole parts of math departments that work just on that. I was at the American Mathematical Society yearly meeting last weekend, and there was one of the sessions on just that. I was, it's a wonderful community, but it's a very abstract community. And frankly, most engineers are afraid of this particular area of engineering because it is a little bit more esoteric, okay? So what we did instead, and this is with my collaborator, now husband, Ken Duffy, is we looked at it completely differently. He's also a math professor. He's now at Northeastern, also in ECE. And we said, well, never mind about creating these really complicated patterns. It's all about noise. What if you just looked at the randomness of the noise and try to undo the noise, right? Never mind Galois, which, whom I love, and you saw I used before, and, trying to create these codes over complicated Galois fields. What if you just said, this is all about randomness, just manage the randomness and try to undo it? And that's what guessing random additive noise decoding is. By the way, he's Irish, and if you've ever spent like 5 minutes on Ireland, you will always hear everything's grand. It's like grand, oh, that's grand, you're grand, which basically means everything and anything. It means nothing. It means, you're doing great, or you're, at death's doorstep, everything's grand. So that was part of the joke in there. And, so again, it started with the math, but I learned a lot from what I had done before. So we started with the math and realized nobody was going to read this. Right. I mean, a very small number of people are going to read this. We went immediately to pair up with Rabia Zizicigil at BU and to build a chip. We built the first chip. The paper appeared in 2019. The chip was presented end of 2021 in SSCirc in Europe. That was the first universal chip with hard detection. And now we're presenting next month at ISSCC, which is what people often call it, the Chip Olympics. It sounds a little funny, our chip reduces the picojoules per bit by over an order of magnitude. But it started in the math, okay? So you start in the math, but then I've learned, you don't sort of sit around hoping for people to come up with it. Now, the funny thing is this time, actually, people were coming up with it. Like, there's now a lot of papers from the circuits community implementing this. So, I'm still happy we're doing it, because I think we're doing it best, because we're the inventors. We're really sort of being able to implement it in ways which are still record-breaking, in ways that maybe the other implementations are not. But certainly learned about, you go from the math, and if you're an engineer, to the implementation. And that's it. And if it's not implementable to some extent, maybe it's not engineering. I just want to stop here, and then maybe just with a few comments, because, they're sort of woven in. But I think that certainly, this notion of taking reasonable risks, but also what I'm hoping also in sharing my views is particularly for you who are going to be in, who are or are going to be in a variety of situations where you're trying to assess, let's call it winners or people who are going to succeed, is to consider unusual backgrounds. And certainly what I do is I try to look at how good a job people did in the past, no matter what that job was. Okay. My student who co-invented, Tracy Ho, who co-invented the random coding, she had been in Singapore managing taxi complaints. And that's really tough, because people come and they're really angry. And this is very, very good. You want people who took jobs that were tough and did them. People who are smart, but I would say not just smart, but smart, different types of, astuteness, diligence, resourcefulness, originality, and most of all, perseverance. And finally, use metrics. Just use metrics. If you're looking for something, don't have a view of, whatever you think your golden young person is, but use metrics. I remember when I was a sophomore at MIT, I was looking for a Europe. And, I printed out my grades, I printed my CV, and I got appointments with a lot of different professors. And, I would show up, and they would immediately look at me and tell me that they didn't have something. And I was all the way down to letter S. Dave Stalin, who departed, very, very dear colleague. And he was about to open his mouth, and before he could, I said, "Can you please just look at my grades? Just look at my grades, And he looked at my grades, and he said, "Let's try it." Okay. So, you use metrics, papers, awards, grades, anything, don't rely on, whatever you thought was, was something else. And I think also, that this is part of also the benefit I was saying of creating something. You tell them and people say, "Oh, that's too good to be true." And you say, "Well, try the software. Here's the chip. That's it." It's like, it's a go, no go, right? Either what I told you is correct, and I can show it to you, or it's not, shame on me, but, either try it out or be done. And so, definitely metrics and giving people tangible things that they can try out, and for you to try them out when people come to you who maybe, it looks too good to be true, I'll try it out, and ask for confirmation, and if they're, diligent and have done their job, then they have. And with that, I will stop and thank you for your attention, and I'll take questions. Yes.
First question is great that you were able to penetrate to a company like Cradlepoint, doing coding and decoding. But I think their product is based on LTE and 5G, and there's a huge, political standard body for 5G, LTE, and so on. So how did they adopt a new coding scheme when there's a body who always pushes in a certain direction, right? And then second one is, how much of it is your name and work from your students going out there and presenting versus how much of help are you getting from TLO explaining, almost like a business development, right? I used to run a startup until recently, and we had business development guys, right, who would go around and pitching to customers. So how much of that is you versus TLO?
Thank you very much. I'll repeat the questions unless people online were able to hear them. Were people able to hear the question? So I'll just repeat the two questions. Thank you for those two excellent questions. So let me say the first one, then I'll go to the second one. So if I can rephrase, the first question was, how can you put this in a system when there is standardization? Okay. So, roughly that's. So what they're putting in right now is the random network coding. And we've had to work around standardization. Okay, so what we've done is we basically are running over the top. So we're doing it at the level of IP packets. And that's where a lot of software-defined networking works. So basically, it doesn't have to touch the standards, and it doesn't matter whether you're working with LTE, 5G, or frankly Wi-Fi. Okay, because my 5G phone, it's mostly on Wi-Fi, right? It's mostly in my office, it's mostly at home, or here, it's on Wi-Fi. So, we're not needing to be in the standards. You also mentioned how political standards are. There's no doubt. There's no doubt. And it's very, very difficult for an academic, to get into standards. It's a tough gig because it's not a totally technical conversation, right? So certainly the approach there has been to just be standard compatible and not, be standard agnostic, let's put it that way, okay? And that was very deliberate to be standard agnostic. Maybe if I can do a little slight aside, I'm in ATIS right now, which is, for North America, the representative in 3GPP. I'm on several committees, including their sort of research directions committee. So I am trying to be involved positively. This is not just sort of a bemoaning. I am trying to get involved positively. And, I'm hopeful that maybe for 6G we may have what I would call more modularity, and it's kind of like a chance to play, not making things monolithic so that there's no space for innovation. So I am very much pushing towards modularity. I'm supposed to be speaking actually next month, I think, at the 6G meeting in Prague on this issue of modularity, and I spoke about it in Brooklyn, at the Brooklyn Summit on 6G at the end of last year. So I'm very much trying to push for modularity so that, the standards are more around, we need the following modules, and then within the module, you do what you you do best you can, right? And that's what I call sometimes the APIization of communications, right? That it's like basically you just have APIs, and you're seeing this from the top, sorry for getting a little bit more about the specifics of this technology, but you're seeing this from the top, with things like Oron sort of coming from the top, but you're also seeing it at the bottom. Of the stack, you're seeing this with, opening up certain types of modulation. So the idea there is to push for APIization, but also be realistic. Right now, we just live with the standards. The second one that you asked is about the role of TLO versus sort of the role of the inventors, broadly speaking, in pushing the technology, right? I think that TLO is there to help us, but pushing the technology, we do. Right, you have to be able to, what I mentioned, for instance, actually come and say, okay, here's the thing, here's the piece of code, or, for instance, we recently put up code for people to try out Grand, because people say, well, some people say it's good to be true, then the chip comes out, and then, say somebody in a company says, no, it's too good to be true, I think she doesn't get it, and the boss comes back and says, they have a chip. Like, oh, okay, well, go and try the code on the website, So that's on us. I mean, it has to be on us, right? Who else is going to do it? The thing is with TLO to have a partnership to enable then the transfer and to have, let's say, high-level strategic discussions about, well, what does this mean? Where do we take it? Is this the right time to do something, or should we wait and see? Wait and see, not as in a passive, unproductive way, but wait and see as in a constructive wait and see. We need to gather more information, and we're looking for the following pieces of information before we take the next step. That you can do with TLO, but the other aspects, what you were calling maybe biz dev. I think a lot of it is on us, because I don't think you can separate that from instantiating and proving the technology, in my view, But, I'd love to hear what other people think in that context. So, yes?
I have a quick question. Do you see artificial intelligence or machine learning competing actually with technology?
So that's a very good question, and one that I get often. So again, for the people online, the question is, do I see machine learning, artificial intelligence competing? So I'm a big fan of machine learning. Occasionally I co-teach our big undergraduate course on it, so I'm fully pro. But I think it's not a substitute for other things. Okay, it's an addition. So I'll give you an example. So on building codes and decoders, the last thing I mentioned, Grand, there's been a huge amount of work on trying to use machine learning to create encoders, so those patterns, and then to create matched decoders. And what we have found, so the theory which goes back to Shannon, who's from the faculty here, literally from the 40s, I kid you not, okay, says that, pretty much any code should do. It's just we didn't quite know how to decode them. Now we do, okay? And actually we have seen in practice that this is true, okay? It actually is true. So, we thought that we would be code mining and doing all kinds of clever things. There is nothing clever to do in the code construction. You can't screw it up, but you have to really try. But, you can use, the most sophisticated codes which are out there in 5G, like CRC-8 Polar codes. Polar codes were created by one of our alumni, Erdal Arakan, who's also from Bob Gallagher's group, so he was some years before me. You can compare those, so the state of the art, with something called a cyclic redundancy check code, which is a very, very primitive code that everything has, with even just choosing codes randomly, and they all do the same. Once they, with the best decoder, which we haven't done the study, but a group at TU Eindhoven has done the study of comparing, these cleverly constructed codes with a lot of effort with, literally random codes, not even slightly shaped codes, and they found it was the same thing, now that you have the correct decoder. So there's an example where you can do it the hard way, but it uses a huge amount of energy, and you don't need to, right? So I'm all for using AI and ML when you have a problem you can't solve, right? But usually it's because you've actually taken the time of writing the optimization, and you see, okay, I have written the optimization, I have stared at it, I understand deeply what's going on, I do not have the tools to solve this without machine learning, then absolutely go for it, right? But you need to understand, it's not a crutch against not understanding the underlying math. That's my view. So it's a really useful tool, but it's not a substitute, because it will use more energy, and you don't know what the heck's going on sometimes. Not always, sometimes you do, but so that's my view. But certainly in this case, we thought that we would be able to use machine learning, and then we're like, it's not doing anything better. It's like, we knew it shouldn't have. We understand the math. So that's an example there. So it's a mixed bag. So.
I have an online question. So any advice to postdocs who are debating between pursuing academia or industry?
That's a really good question. So I think everybody heard that online and not online. I think that it's not necessarily that you do one or the other. As I said, when I graduated, I didn't want to go into academia. I didn't see myself in it. And I came to it because I realized that the kinds of things I was doing that I really liked would be amplified in academia. So first of all, that whole raising money thing, which sounded just terrifying, it always is terrifying. It's never going to get away from being terrifying. But somehow it was terrifying, but I could do it. And the fact is, whether you go into academia or you go into industry, you're going to have to do it anyway, right? The idea that you're going to just sit in an office and, do your thing and somebody else is going to bring you the money, maybe for a year, and then you're going to have to do it anyway. So, deal, right? So that shouldn't be the issue. The other one is, I found out I really liked supervising students. I think that's the biggest difference between the two. So certainly when I have postdocs in my group, and as mentioned, I try, I take mentoring very actively. I try to make sure that they have interactions with students. To me, that's the biggest difference between the two. Do you want to actually be mentoring students? Not that you won't mentor in industry, but it's going to be a different portion of your work. Or do you really just want to concentrate more on the technology? And I think that in the end, that's really the biggest change between the two, whether you really want to take the educational role or whether, you want to substitute those hours of education for more technical work. And by the way, I was surprised I liked supervising students. That was not something I wanted to do. Again, sort of just took an intern just to see, whatever. And I really, really liked it. I really got pulled into it. So if you have that need to mentor and educate, go into academia. But otherwise, I would say don't. That would be my advice. Yeah. Other questions? Oh, you have another one online?
Yep, we have a few more online. What did you find the most challenging when doing a startup as an academic? In your opinion, what did you find most helpful when working with the TLO?
Yeah, so what did I find most challenging? I think that I was getting a lot of advice, much of it good, but not all of it consistent. And I was having a little bit of trouble navigating that. I mentioned some of the mistakes I made, assuming that people could just take the technology and just transfer it on their own. And I think that also understanding a little bit more the needs of your interlocutor and figuring out early on if it's going to work or not. So I spent a lot of time trying to explain stuff to companies that, were just not ready at that time. And it's very, very time consuming. Now, again, going back to the whole educator thing, it's kind of like, that's what you do, you're passionate about it. And I learned a lot from what their needs were from that, okay? But maybe, I would have been a little bit more deliberate, or maybe it was a little bit scattershot, but again, I put that on me, and I think I should have waited more until I had a piece of software, right? Then I came back to them, I said, I know what you need, here's the software, try it out, and then once they try it out, they take it. It's all about trying it out. Please just give me a chance. Look at my grades, look at my software, okay? I think what I found most helpful working with TLO is, and I had to learn this over time, is again, sort of having a little bit more of a discussion about the strategy and where the technology might sit, rather than just about what the technology does. Right? I mean, obviously, you know what the technology does, and obviously you should be able to explain it, and, you should explain why this is worth MIT investing in it, and et cetera, right? But the other aspect, which is around doing a little bit more of the strategizing, that's something which I think I learned as I went along. And also to come up with things that are positive, right? But I think that's not, like I had one of my patents, for instance, licensed, and, I wasn't happy about the company got licensed to. I was like, they won't know how to do it, and I was right, But it's like, thinking back, that's not useful, okay? Either, propose a different company that's going to do it better, or do it yourself. Well, shut up, Muriel, So I think, coming also with things which are more useful, right, and strategizing, I think I've learned that. And it carries to everything. I think it carries to everything. So, you said you had another question?
Yep, absolutely. Another question from online. How has patenting improved your science?
That's a really good question. I touched on it very briefly, but I didn't go much into it. So if while you're writing your paper, you start thinking a little bit, or you actually write your patent around the same time as you write your paper, both will benefit, okay? I used to write my papers and post facto go, okay, let's shove it into a patent and see what happens, shoehorn it. Not the worst thing, by the way. Not the worst thing out there. You can come with very good patents. If instead you start thinking a little earlier on about the interplay, what happens is then when you're thinking a little bit of drafting the claims, and of course, by the way, you should work with a professional to do your claims, right? I mean, the same way that, you shouldn't do your own electricity and things like that, okay? But at the same time, it doesn't mean that you're not already thinking, or maybe you can sketch out what you would like, okay? And maybe sometimes even taking the time to just draft the main claim, which of course, an attorney will look at and go, ha ha ha, that's cute, and turn it into something professional. But just at least that intentionality. It means that, you need to be a little bit more clear about. See, very often if you're writing a journal paper, you say, people have been looking at the following problem, reference blah, 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 blah. In this paper, we do this. Okay, you don't do that in claim 1, right? In claim 1, you say, we do this. And you say what you do. You don't say what you don't do, right? Which is often what we do in academia. It's like, oh, and I don't do this, and I don't do that. And let me tell you all the other things I'm not doing. And there's something about being positive and explaining to people exactly what you're doing, rather than what you're not doing. Which actually makes it better in writing the paper. It's more positive and it's better guided, but it's also what you need in your patent. And specifically, when you're thinking of your abstract and saying, what is it, what's the essence of what you're doing? This is a method and apparatus for doing what, And if you had to tell me very briefly exactly what it needs and what it's doing, what it needs it inputs and what it outputs, what would you say it is? So I think that has been, to me, a very, very good experience. As I said, it really benefits both. And certainly then with a patent, I'm not sort of post facto going, oh, well, I should have said this in the paper, or I didn't explain it properly, or, I'm not separating what's the essence from what are sort of, requisite, formulaic, academic needs for the paper to get through, that at least in your head, you have it well separated. So. So I think we were supposed to go until 10. I know we started a little late, but I don't know. I'm going to let you figure it out. We can also take things offline. Pardon? Okay, yes.
I love your talk, how you contrast and receive wisdom versus your own career. I have a daughter who is 10 and she loves math. So I'm curious about where you mentioned, like during your teen, your aptitude for math, I guess, changed. Curious, just a little bit more, like what exactly happened? Was there someone who inspired you? Was it somehow, it just all made sense? Just curious about your own experience.
My own experience, yeah, thanks. And it's great that your daughter's already interested. I think I wasn't finding it very interesting at the time. So sorry, just to repeat. So the question was about, what made the math sort of tick. I think, the questions I was being asked were about, when trains would meet and things like that, which, sounded like a pretty dull set of musings, like, I don't know when the trains are going to meet in the middle. Why are we considering this, rather uninteresting problem, right? I mean, so I loved languages. I was definitely very interested in languages, but I hadn't found the side of math very interesting, so I kind of neglected it, frankly. And then I decided I just didn't want to not be good at it. Like, it was annoying. It was just like, I was annoyed. I was like, okay, I'm going to figure this out. This is annoying, right? And I just decided I was going to sit down and figure it out. And then once you figure it out, you're like, oh, this is pretty cool, right? I mean, a lot of things are annoying because you don't understand them or because you haven't spent the time. So, actually sitting down and figuring it out was important. So I would put that not so much as an aptitude to math, but just a desire, an attitude rather than aptitude, if I may. It was more my attitude to math changed. And I said, I'm going to figure it out. And then, you know, once you start figuring it out, you can, you know, one thing flows from the other. The good thing about that is there will be many times in your career where you start out in a field or in a class or in a domain where you are absolutely out at sea. Okay, just absolutely out at sea, and you have to figure it out. You know, and I think that's more an attitude. And I think very much, you know, when selecting people on the team, you know, anybody who has figured stuff out, maybe because, you know, they were thrown into an environment that they didn't know. I mean, my parents traveled a lot, and then they would, you know, send me to school, and I'd come back and say, they speak another language, and the answer was always, figure it out. You know, and it wasn't like, okay, honey, we'll support you. It was like, no, just go do it, you know. And, you know, thinking back, it sounds a bit weird, but there's something to be said for that, right? So people who have done stuff and figured it out, whatever it was, you know. I mean, I think math is particularly nice, and it's been particularly useful. I'm not a mathematician, I'm an engineer, let's be clear, you know. But, you know, when I came to MIT, I didn't think of majoring in engineering, for instance. I didn't know about engineering. I was good at math, I liked math, I liked literature, I thought I would do those too. Don't ask what I was thinking I would do next, I didn't have an idea. And I took a class in engineering, just everybody else was, you know, what the heck, try it out. And what I loved about it is it had the rigor of math, right? Which once you start thinking that way, you can't go back, right? You can't start thinking in a rigorous fashion, then go back to fuzzy thinking. It's a one-way street, right? Which is great, right? Annoying, but great. And then I liked the more creative side of literature, you know, that you could think about what ifs and, you know, develop different ideas. I mean, there still was some sort of rigor, but it was much more creative. And, you know, engineering has both. You're thinking, how good can it get? You know, you can be creative and, you know, come up with things that can give people a lot of satisfaction, including, you know, first of all, yourself, and it's rigorous. It's amazing, right? So that was my road into engineering, but I didn't even start out thinking I want to be an engineer. I think a lot is also about being open-minded. And then when you decide you're going to do something, put the effort and do it well. And it doesn't matter if you're teaching aerobics or, you know, starting a company. Like, okay, I've committed to doing this. I'm going to do it while I'm doing it. Thanks. Yeah, but I think a lot of it is about attitude rather than aptitude. And I see that a lot, you know. You know, people with aptitude, there's tons of them. There's just tons of them. So, okay.
We have one right here.
Yes.
So as kind of a recognized expert in network coding, can you talk a little bit about the balance between getting approached for corporate-sponsored research and keeping things to a level where, you know, you may want to invest in it as a broader technology without having necessarily a single corporate sponsor that you have to worry about deliverables to?
That's a really good question. So I'm going to sort of rephrase the general question more as a question of, you know, selecting sponsorship for different technologies. So maybe let me just take a step back, and I may go a little bit in the weeds to answer that question, but, you know, so, you know, as academics, we raise money. I've mentioned it. You know, that's particularly if you're in engineering, you have to do certain work, and that work costs money. That's all there is to it, right? So you have to convince somebody that they should invest. Certainly, if you're looking at sponsors from government, you know, there's government rights, you know, Bayh-Dole Act and all that stuff. You actually have then technology's rights reside with your institution, okay? So certainly in terms of unencumbering the intellectual property, that is, you know, let's say the most attractive, right? I mean, the most attractive, of course, of all is just money with no hooks attached, and there is some such money. Actually, MIT gave me some such money to get grant started. So, that's I would say, exceptional, rare case of, the core patents having no attachments whatsoever, no encumbrances. However, naturally in the evolution of technology, there will come a point when you need to be a little closer to the use case, right? And at that point, changing your mix of sponsors so that you have more industrial sponsorship makes sense. Okay, so I would say for network coding, I started out probably being like, 90% government funded, and then I moved to being maybe like 50-50. Now I'm probably like, 30-70 governments versus commercial sponsors. It's actually healthy. Now, do you have to worry about, possible encumbrances and, the IP issues? You do. I've had many cases where, going back to how to work positively with TLO, if TLO tells me this cannot be done, we cannot figure out how to make this contract work for both parties, you just step back and you go, okay, can't do it, I trust you. You could do it, we would, right? And, just be able to, step back and say, it'd be great to work with the sponsor. They have some really interesting projects. They have fantastic engineers I'd love to work with, but it's not going to happen. Okay? Sorry, it has to work for everybody. But certainly when it works, it goes very well, and it really allows the work to progress. Going back to the issue of business development, there is sort of this in-between zone sometimes when things are, if you will, too developed for an NSF project and not sufficiently developed for, still need a longer runtime than what you would do for an immediate tech transfer, okay? And I think this is not an unhealthy zone to be in. You were talking about deliverables. Deliverables are good. Okay, this is, the day before a report, this is not what I'm saying. But by and large, deliverables are good, right? Because most of the deliverables go back to this issue of demonstration, right? Usually it's because the deliverable is, okay, show me this. Did you do it? And if you've agreed to the deliverable in the first place, and of course you need to work closely with your sponsor to make sure the deliverable is sensible, then it's probably because you've agreed that this was a good idea. Now, things may change. You may say, look, I don't think this is the best place to demonstrate that. I would like to demonstrate in this other use case. That's fine. That would at least force you to have the conversation with the sponsor about, we've discovered certain things. So worrying about deliverables is actually good. I have to tell you, deliverables have more than once saved my projects, okay? The go, no-goes, as I say, the DARPA go, no-goes, which, many people speak of with, spite and four-letter words, they're fantastic. For me, they're fantastic. I'll give you another story about, kids and, I remember I had a DARPA project actually on network coding, and actually DARPA has been very, very generous, and they're massively backing our grand decoder. But, we had a review, and people came to MIT, and I had my presentation, and there was no school that day, and my babysitter was sick. So I show up with 3 kids and 1 baby in my arms, and I'm the only woman in the room, and I make my presentation, and people go, well, is this going to work? And, clearly this was not good. And, my program manager would, get along with him very well, but how to talk with me about, this is not professional, blah, 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 and, I want you to go next time to the other presentation of the other group and see how it's done. And I go, and there's no kids, and everybody, I'm the only woman again, everybody's wearing a tie, and, it all looks like, okay. I'm like, okay, whatever, In the end, you give them the software, and they try it. This is the red team. You had to do 5 times better than the current state of the art, right? Theirs did not work. Ours did 10 times better, 10 times. There was no more talk about, your kids with cream cheese on the face and, the baby on your lip and, literally drooling, looking at the, and I was like, look, I'm sorry, I don't have, I am where I am, and so, having those metrics, for a lot of people, that's what saves you, right? It's like, I'm not coming across as what people expect. I totally understand that, okay? Whatever, but, I hand the thing and it works. And it works really, really, really well, okay? So that's the deliverable. I want deliverables, actually. Because that's what also allows me to compare better to the other groups. Which I know is maybe not a popular view to want more deliverables. And I'm not saying more, but the right ones. I think it's a healthy thing. I don't know if that answered your question. Yeah.
Thank you. My question is, it sounds like you've obviously worked with a lot of industry partners. And so for industry partners who are thinking about potentially collaborating with university researchers, what do you wish they know or would do more of to enable that partnership to be more successful and long-term and prosperous?
That's a very intelligent question. Thank you. That's a very, very good question. I think partnerships happen in many different ways. I've certainly had very successful partnerships that started with the Industrial Liaison Program at MIT. That's been fantastic, and I think is under the same umbrella as TLO, right? Many of them are just colleagues in the field, right? So if you're very active in your field, you will know people, and they will know your research, and you will have conversations, and things will get started. In my field, I think maybe the thing to know is that in the end, the work is done by PIs, by principal investigators. And there has to be a connection and an agreement with the principal investigator. And it's not just with the institution. So it can definitely start at the institutional level, but all agreements have to be with PIs. And that it's those pairwise agreements that are important, in my view. Or at least there has to be a PI who is then connecting with the other PIs positively. In the end, it has to be a person leading the group, doing the work. So it is about the PI more than the institution. I don't know if that's a useful answer or if that's the kind of I don't know if I answered your question or not, because it's a very rich topic.
Yeah, I guess I'm curious, for an industry partner that haven't kind of worked with university researchers before, and they're hearing about all the success, especially like the startups that are spinning out and raising a lot of money, and they want to kind of be part of that journey. What can they do to help move stuff from lab to market at a faster rate that can be both beneficial for the researchers as well as for the companies?
Yes, I understand better. Thank you for that clarification. Just for everybody, it's how can industry partners be positively involved in the transfer from lab to market? So I think it's again talking to the PI, because the PI will understand best what is the state of the technology, You know, what things have been demonstrated? What things have yet to be demonstrated? What things are well known? What are risks? How can those risks be managed? What is the interplay between their technology and other aspects in the market? So, you know, going back to the first question about, for instance, standards, you know, does it matter if this is in the standards or not? Things like that. And I think the reason that needs to be a conversation is because, you know, we publish, right? We publish, and you can read our papers, you know, with enough coffee and, you know, diligence. You can read them, and, you know, you can make out what they say and so on. But we don't have those other aspects in the public domain, right? You don't write a paper generally about, let me dish to you on, you know, who's doing what. That's not a paper, right? That's a conversation. So that knowledge is there, but there is no sort of recognized vector for it. Maybe one of these fora is, obviously, but you know, these have to be conversations which occur, and which generally don't occur on the first conversation. Right? There has to be some period of sort of, if you will, mutual assessment of fit and trust and alignment of interests. And then when that happens, then there has to be, but it has to be a conversation, I think, at the PI level. So not that there aren't, you know, obviously fantastic, more institution level efforts, but in the end, if you want to concentrate on a specific technology, it has to be with the people involved deeply in that technology. If that's your goal, rather than just encouraging or sort of helping a larger ecosystem. So certainly, you know, in terms of just helping a larger ecosystem, you know, there are all kinds of centers and so on which can be extremely useful. But you also a lot of research that happens outside of those, right? So, you know, depending on what other people are at that institution, there may be, you know, a center or an institute, or it may just be just a PI with, you know, occasional collaborations. Certainly, I'm more in the latter category. You know, I'm very collaborative, but it's, you know, it's more I do my own thing. I don't know if that helps. Yeah, but you know, obviously different people work differently. But in the end, you have to have that PI connection. Is my view for it to be truly successful. Okay. Yes.
Sorry, just this last question.
I actually want to follow up on that question, the lab to market, and you know, in terms of connection with PI question, is how much is it kind of you go out and find them versus creating I guess a pathway that they could easily find you and your work, and you know, and what like in terms of your career from the beginning to now, like is there a difference in terms of how those interactions and connections are made?
Thank you. That is a very good question. It always has to be mutual. So, you know, you go and talk to people and they come to talk to you. You know, and especially once you have relationships, you have people that you can call and say, look, I have something really exciting I want to tell you about, right? And then every so often they ping. So it's a pull and a push. It sounds really fuzzy. I'm not being coy. It really is difficult to do a clear taxonomy. You know, there are cases where I've had, you know, as I mentioned, you know, sort of cold introductions to ILP, which have gone very well and, you know, are still ongoing. There are cases where, you know, I'll know a ton of people at a company, and I have lots and lots of connections, but I can never manage to work with that company, you know, because structurally for that in that company it won't work. You know, there's a different, you know, different priorities or different MO or whatever, right? So, you know, the best case scenario is you know people at the company, you have connections, there is already, if you will, some sort of intellectual matching, where you kind of know what they're doing, they're interested in what you're doing, and and so it's there's a good environment. I mean, certainly as you get on in your career, it becomes easier, right? It becomes easier because you're better known, and of course you pick up more experience about how to interact in a fruitful, going back to one of the words I was used, in a fruitful way with companies, how to be more understanding of their needs and ask the right questions. I think that for companies, maybe one thing to bear in mind is, faculty do get asked a lot. So it's very useful also for the companies to be, how would I say, positive and purposeful in their interactions, right? So, a lot of companies come and then they just sort of want to talk to you, and you spend an hour, 2 hours, and then, 9 months later they go, oh, we want to talk to you, but nothing, there was no follow-up. I've learned to be much more, polite, but, to be much more purposeful and, politely say, it's fine to have an introductory, meeting and see where it goes, but then if it doesn't go anywhere, you can't keep doing that, right? Because, what I've said a few times is there's one of me and there's 10 of you. It's like, figure it out. It doesn't scale, right? So certainly I think for companies it's good to be respectful of faculty's time, of anybody's time, and particularly when you come and ask somebody to have a meeting. And then to be careful in selecting the most informed people inside your organization, or not. If you want something at a higher level, and then maybe select. But to be thoughtful on both sides. I have to be thoughtful, but the companies also have to be thoughtful. Certainly, companies develop reputations, right? And those reputations do get around faculty. So some develop a reputation for being, good partners to work with, and some develop a reputation for being for not leading to productive outcomes. You don't want to be in the latter category. And you do want to be in the former. But and it's like with students or postdocs or anything, it's just you try to treat people well, and typically becomes fruitful. Great. Thank you very much. Thank you.